Hello, welcome back to my YouTube channel, guys. We are here again with daily Leetcode question. So today's question is minimum cost walk in weighted graph. This is Leetcode hard question. So the description is there is undirected weighted graph with n vertices labeled from 0 to n minus 1. You are given an integer n and an array edges where edges I is equal to ui, vi, wi indicate that there is an edge between vertices ui and vi with weighted of wi. So there is a very long text, so I can make simple for you. Well, we have given an undirected weighted graph with n vertices. Each edges between two vertices has a weight of w. So a walk in the graph is a sequence of vertices connected by edges which may visit the same vertex or edges multiple times. So we can visit same vertex or edge multiple times. So the cost of walk is defined as a bitwise AND of all edges weighted in the walk. For example, if the walk encounters edge weights with W0, W1 or W2 uh, until wk, the cost will be w0 w0 bitwise and with w1 bitwise and with w2 bitwise and until wk. So we are also given a list of queries. Each query si or ti asks the minimum cost of walk between vertex si and vertex ti. If no such walk exists, then we return -1. Like given in this example, you can see we can return -1 also, there -1. So enough of the talk, let's jump right into the code. So what we do here, we make compare and a dictionary, okay, to store bitwise and now we declare a variable named parent that will be an array to keep track of connected components using disjoint set union approach, also known as union find approach. So for that we will use list comprehension for I in range of n. Okay, now we will use three helper function. One of it is find with I if parents of I is equal to I then we return I. In else case we set p is equal to find parents of I and parents of I will be equal to p and then we return p. Okay, so this find the root of parent node or of a parent of node in our disjoint set, and path comprehension is used to make future queries faster. Okay, we are using path comprehension. Now we implement union. The parameters will be I comma j comma k, sorry, w, and now the capital J represent find of I, sorry, find of j, and for simple capital I represent find of I. Okay, now we check if I is not equal to j, then we set parents of I will be equal to j and our bitwise comparator dictionary will get stored with j will be equal to, we will get j from it, and dot get j and otherwise w, and comp and dot get, sorry guys, little spelling mistake, get I comma w, and if there is no I and j, then we get only w. In the else case, comp and of j will equal to comp and of j and with w. Okay, so this will merge two component sets, and if I and j belongs to different components, then we merge them and update their bitwise and cost. If I and j are already in the same component, we will just update their and cost. Now we will process all the edges. Okay, for that we will use for a, b and w in edges, then we call union function a, b and w. Now what is do, it will connect all the edges using the union function. This group the graph into connected components and stores the and cost for each component. Now we process each query. For that we will make answer variable with empty list. Now we use for a, b in query a comma b will equal to find a will be equal to find a, and b is equal to find b. Then we check if a is equal to b, then answer will be append with component of a, okay? Component and of a. In the else case, the answer will append -1, append -1. Now we simply return our answer. Now we run it, and we are getting error for this. Now we run it. Let's hope there is no typo. There is no typo. See, all test cases are passed. Now we submit, and see, we are getting good complexity with 137 millisecond. This approach will get you the time complexity of O of n plus q, and it will be efficient for large graph, and the space complexity will be big O of n. So thank you.